Good morning, everyone. It's Monday morning, it's K2022, and it's crowded. And we're happy that you have actually found the time today to come and spend some time with Milliken. We have some experts for you to listen to, and we hope that you will find it interesting. Today, the talk is entitled Orange is the New Black. And it is a mysterious title, which I'm sure we'll get to understand better once we've got the presentations. Just as a little commercial for ourselves here, the Tech Talks are regular talks that Milliken has staged here at the show to allow outside experts and collaborators to explain how they're working with Milliken to make the future more sustainable and advance the company and everybody who works with the company into a more sustainable future. Today's speakers are Esther Wessels, who's standing to my left, to your right. Esther tells me that she's a freelance expert in color and analysis. Did I get that right, Esther?
You got that right.
Excellent. And on my right, your left, is David Caro, if I say that correctly.
That's correct. You got it.
And David is Advanced Development Engineer in the Plastics Group within Milliken. So without further ado, I'm going to ask Esther to kick us off. Thank you very much.
Thank you, Willem, for your kind introduction. Going straight to my presentation, plastics are a very diverse and large group of materials with an enormous diversity in material properties. Roughly, they can be divided into two groups. First, the low-grade plastics, which are relatively cheap, where the usage requirements are relatively simple. The most well-known are polyethylene and polypropylene, which are used in all kinds of home, kitchen, garden, objects, and foils. It is by far the largest group, with an annual production of about 200 million tons. The second group is the technical high-grade plastics, which also includes engineering plastics. These plastics, which are relatively more expensive, are used in more complex applications, where higher demands are set on the material and the processing temperatures going up to 300 degrees Celsius. About 30 million tons of this is produced every year. In recent years, another group has been added that is an extension of engineering plastics, but has been set aside because of the extremely high processing temperatures, going up to 370 degrees Celsius and even above 400. The so-called high-temperature plastics. This group is gaining market share, especially for the new applications of recent years, such as electrical cars. Think of lamps, high-voltage charging systems and wiring, but also soldering of all kinds of components on motherboards. By the way, this classification undervalues these materials because each plastic, low or high end, is precisely fitting the function for which they are used. So where do we use engineering plastics? Consider the home electrical panel. All fuses are made of engineering plastics. Consider the car, interior, mirror housings, engine covers, manifolds, hoses, tubes, and even the cover for a gear lever. Consider your home, kitchen and garden, your coffee machine, toothbrush, computer, mobile phone, drone, grass cutter, electric saw or drill, and lighting. Consider healthcare, surgical clothing, masks, glasses, and respirators. Consider your home interior, chairs, carpet and rugs. Consider safety, home alarm systems, window frames, motion detectors, personal or senior alarms. So the question is more, where do we not use it? From the time they were discovered and developed in the earliest 20th century until today, engineering plastics fulfill our increasingly higher demand and requirements because they are, with the right equipment, easy to shape and process. They are wear resistant, can be insulating and protective, strong, yet lightweight, and in all possible colors. And we need colors in our lives to attract, differentiate, personalize, distinguish, and alarm. However, with the increasingly complexity of the applications and requirements for the properties of the materials, the need for higher quality and demands for colorants also increased. Not in the least the requirements on safety and sustainability. An important example on how this influenced the coloring of engineering plastics was the complete abolishment of cadmium pigment, where cadmium is toxic to humans, especially when inhaled. Until today, the world of engineering plastics has no answer yet in replacing this pigment group, especially in orange, because inorganic pigments are very thermally stable but have limited color strength and mostly an enormous effect on the material properties, especially in glass reinforced grades. And organic pigments and dyes do have the needed color strength to match every color, but have limited thermal and oxidative stability and cannot be used in every plastic yet. So here we are today with all the new challenges we are facing. The ban on single-use plastics, increasing availability of bio-based plastics, increasing demand of sustainable applications, subsequently needing high-temperature plastics, and increasing developments in technology on recycling, compostability, and depolymerization. With both the existing group of engineering plastics and the new, even higher temperature plastics of today's and future applications in need of new colorants. The plastics producing industry is looking for answers from colorant and additive manufacturers. New technologies need new answers, a broader perspective, looking further than what you know and have experience with. Broaden your horizon. So the answers may very well not be found with the suppliers of the past, but the manufacturers of today and tomorrow, like Milliken.
Absolutely. Thank you so much, Esther. And I
I
first
give it
want to
to
thank
you.
Esther for being here. She really, in our industry, is such an expert when it comes to engineering compounds. So any sort of resin that are going to be replacing a lot of these metal parts, but also in color as well, which when you synthesize those two kind of groups of coloring and engineering compounds is really difficult. And so as we talk about the future of plastics, as we talk about a growing market when it comes to electric vehicles, it's an honor to have Esther here to get to lead this alongside of her because of her expertise in that area. So thank you again, Esther,
You're welcome.
for being here. Right, so why did we title this Orange is the New Black, right? So on traditional fuel-based automobiles, if you were to open the bonnet or hood of the car, right, everything is mostly more or less black, right? And now as we introduce electric vehicles onto the market, right, I don't have one yet, but I know that pretty soon about everyone in the room in the next 10 years or so will probably be driving one, right? If you open the bonnet or hood, a lot of those parts are colored bright different colors in order to indicate electric current that runs through them. And a lot of that is mandated by law, but also through the OEMs who want to let the manufacturers as well as the users of the vehicles know that this is a high voltage application. So what we're talking about today is our new color for this specific space. So it's a powder colorant designed to meet these specific challenges. But while you're waiting in suspense on exactly more details about our solution, I did want to talk a little bit more about Milliken and why we're the right partners for these types of projects. So Milliken is a diverse manufacturing company, from textiles to healthcare to floor covering to plastics. we really are a sustainable company with really great expertise in research and design in all of these different markets. And it's that diversity in our manufacturing that I think really allows us to innovate and create new products for new markets. So before, again, when it comes to color specifically, Milliken has a great history and a very rich one in the diversity through different applications in color. So it actually all began, so I mentioned that Milliken is also a very large textile company, and so many of its origins actually began there. So some of the first innovations in color actually came through the textile industry. So many of these different materials and fabrics, before they're processed, the manufacturers need to know and be able to identify different materials when they're on the racks or in the rolls. And so Milliken developed polymeric colorants that actually stain or are kept into these materials to distinguish when they're on the shelf. But then as they're processed and in the manufacturing process when they're washed, those colors actually come out. And so it's through that type of polymeric technology that Milliken really began its story with color. And of course, it didn't end there. So you can see, and if you take a look at our booth, and we have many representatives here to talk about all of our different products through color, but really it's been a rich history in a variety of different applications. From agriculture, so whether you're covering with fertilizers or different identifying measures for different agricultural products like seeds, whether it comes to liquid inks, or I have an 18-month-old son who's not quite into markers yet, but you really want those to be washable so that they come out in fabrics and don't stain your entire house. But also with our clarifier technologies, our clear tint line, which is polymeric colorants that give really great transparency in polypropylene. So those are just some to name a few, and I'm more than happy to talk about all of those. But really, why did I mention all of that color history, right? It's because as we think about new markets, new materials, as Esther said, you really need a company that really understands these new markets, that is on the verge of discovering new items. And when we talk about plastics in 2017, when we launched our product line, specifically our dyes and pigments for color, this is just a growing new product that's in that portfolio of existing products that we have. So again, Milliken are color experts and want to continue to grow along with you, whether you're a compounder, a master batch producer, or a raw material supplier to be able to meet those needs. Right? So now to finally our solution, right? So if you've ever worked in a color matching lab, and I have worked in a lab, you know that oftentimes you get target parts that your customer wants you to match, and they're really bright and they look great on a shelf, or you might have a target like a RAL 2003 or any of the other bright standard shades, and that looks great and the customer wants those because they, as Esther mentioned, they indicate a specific purpose, so in this case, high electric current. But if you've ever worked with nylon 6 or nylon 6,6, or if it's contains glass beads or glass fibers, or if it contains flame retardants or heat stabilizers, you see that often the resin is not very clean and clear. It often looks like this, right? It's opaque because of the glass fibers. It's often brownish or greenish, even just naturally it's on its own. So to be able to achieve a really chromatic color is really difficult. And there's a reason that people haven't been able to really necessarily make these great parts or get to these colors quite yet. Or if they have, right, they're unsustainable solutions. The manufacturing process is really difficult. And so to be able to use those moving forward is not something as part of the industry that have been accepted quite yet. So our new colorant is called the ResistXTR 9798, and it's an orange powder colorant designed for you if you're a master batch producer or a compounder. And so what it is it's designed specifically to be used at about a 0.5 to 1% in the final part, comes as a powder just like the rest of our pigments and dyes, and it's designed to meet a couple of different specific requirements. Number one, right, is the color, right? You need something that's gonna meet that nice, clean yellow shade orange to be able to manufacture these parts. Number two is that it needs to work in a lot of these engineered resins, right? There are a lot of dyes that may work in PET, pigments in polypropylene or polyethylene, but in nylon specifically, with that amine group on the actual resin itself, right, the polyamide, it's very reactive. And so most chemistries for a lot of dyes and pigments don't work well when they're being extruded or processed. So to have a chemically stable colorant is important as well. Also, if you can imagine, right, for the entire life of your vehicle, you won't just have your vehicle hopefully for just about 1 year, right? You want to have it as long as it will possibly last. And so when you open the hood of your car on day one, when you drive the car off the lot, you need that part to be orange to indicate the color. And then when you give your car away to your son or daughter who's going off to college, right, you also need that color to still be orange, to still retain that same indicator purpose of high voltage. And so it's because of that that a lot of OEMs are requiring what's called the 1,000-hour heat aging test, right? They want to see that these parts, which are going to be exposed to heat over the entire life cycle of the vehicle, are going to be able to withstand the energy that's going and passing through a lot of these parts. So that's a common test that is required and something that our product meets. And again, right, if you're anything in this market, it needs to be consistent and the quality that is needed, right? You want consistent from batch to batch. You want it to continue to be orange, no matter if you're matching it on day one with a sample from us or if you're manufacturing it through your compounds or master batches. So we're excited to say that we are officially at K-Show launching this product. And so we are very excited to partner with you to be able to meet these different requirements. Right, and so I mentioned a little bit of those. Again, it's suitable for all engineering resins. It has a heat stability of about 305 C, which is typically meets all the requirements for a lot of these applications that are being used in these material replacement opportunities. And again, really when you work with us, you are working with Milliken, who are color experts, but also experts in quality as well. Right, so again, I mentioned this is where we want to get you. We want you to be able, like I said before, to have a color match come into your lab, a compound that you need to produce for a customer, and for you not to be scared or say, we can't match that, but to be able to use our colorants to be able to match those. And again, this product complements our other products as well. We have an existing line of resist products that are typically used in these resins already. And so now with this orange, we really think you can meet your color match targets, as well as these requirements for these electric vehicle applications. And again, one piece of data that I did want to show, and we're more than happy to share offline a little bit more information in some of the studies that we've already done. But this is one example that we've done in 30% glass-filled PBT, a very opaque resin on its own. And you can see typically the test is done at either 120 or 130 C. So we conducted this test at 130 C to be able to understand how our colorant performs. And you can see, obviously, it does fade ever so slightly over time because of that, because of the heat that's applied, but it's below that 2 to 3 DE range, which is necessary for these requirements. And really and truly, with that very abusive test that's done, you can still get that really chromatic orange for these requirements. Something that's ongoing, it's being approved by OEMs as we speak, and we're excited to partner with you as you have those opportunities as well to support this growing industry. And really, the last thing I'll say before we kind of have some questions, and hopefully you have plenty, is this opportunity came about because we're really thinking forward in what the future has. And if you are at K-Show, you know that e-mobility, electric vehicles have been such a topic for the show, but also sustainability as well. So when we think about industries like the electrification of vehicles, alternatives to fuels, this is a growing part of how materials can be used, and plastics specifically can continue to be used in these sort of applications. And with that, I'll turn it back to Willem. So thank you.
Thank you very much. That was very enlightening. I recently bought an electric car, and I thought it was just, initially when we were talking on the phone, I thought it was about the color of the car itself. And I have a blue car, so I didn't know where this was fitting. But then Esther pointed out that I had to actually open the bonnet to see the perfection there. David, one of the things you didn't mention was, is the product available now?
That's a good question. So absolutely. So it is available. So we have about 200-gram sample sizes, both in the United States and in Europe. So wherever your company is located, whichever makes more sense, we're happy to ship those right away and they're ready to go. If you need a larger sample, then we can talk and see about getting you either multiple samples or maybe a larger batch depending on your project. And we're more than happy to collaborate and talk with you more on those. And we also have material available as well. So we have production batches that are on color and look great, and we are just waiting and working on you to be able to ship those to you.
Thank you. And Esther, you said this is a major development in engineering plastics because it's for the first time in 20 years, I believe.
Yes.
Do you want to elaborate on that?
It's, as I said, since the abolishment of the cadmium pigment, the plastics producing world has not recovered. And until today, there is that situation where we work with what we have, but it's not great. So you have the issue with inorganics and material properties. And yes, there are inorganics that can be used without influencing the material properties, but they are not always sustainable. They are not always stable in terms of batch-to-batch differences. So there's a huge challenge to get to the right color. And if you have to make a very chromatic color like this application, then you need chromatic colors. And what you see often is that the existing, for 20 years already, existing group of organic pigments and dyes, they are chromatic, but in terms of stability and also issues with migration, it's a challenge. So we embrace, as the plastic producing industry, every new dye and every new pigment that can fulfill these requirements.
So well done, Milliken.
Well done, Milliken.
Right, I'm sure that there are lots of questions here, so feel free. Do we have a microphone for the audience? We do have a microphone, so is there anyone who has a question? Don't be shy.
Hello, David. Carlos Caro from Grafe. Can you tell something about the processing of the orange in PPA, PEEK, PPI specifically, because these materials have a melting point above 300 degrees, so the processing temperatures are quite harsh. So it could be good to know what is your experience with these materials.
That's a good question. So our colorant is specifically more designed for nylon 6, 4.6, and 6.6 because it does have a heat stability of about 305 C. We've had some customers try it with some success in some PPAs as well as some PSU and PEEK. So we would recommend more testing that'll be done, and we can collaborate and discuss more. But thermal stability is around 305 C. There are some grades of PPA which are processed or extruded below those temperatures, so it can make sense. But if it's above that, let's talk. I think that this can be a great option to take a look at, but it would depend on the processing temperatures as well as the specific application if it would be a good fit for those opportunities. But great question. So definitely not ruled out. I think there's good opportunities.
Which means that the certain group within the high temperature plastics can already be colored with this grade. The polyamide 4.6, for example,
right,
is already a very high temperature grade, but the new PPAs and PI and PEEK, they are even higher, and it might be that that is also an opportunity for Milliken because of the history also in working with all kinds of additives that might in the future result in another one that can perhaps withstand
Absolutely.
even higher.
Absolutely.
And maybe with the correct stabilizers, this one can already do a whole lot.
Right. And that's a great point as well, is we know that a lot of your compounds or master batches are going to contain a lot of flame retardants, heat stabilizers. So that's something that our product, we know, works very well with those. And we want to collaborate with you to understand for each individual project that you're working on, what those different requirements are and discuss those as we work together. Thank you, Carlos.
And may I add to that? I cannot emphasize enough that you need to collaborate. Don't look at it that, okay, it's 300 and I need 370. Let's stop the show and do anything. I think a collaboration and getting your own materials tested with what it can and cannot do, maybe with a package of stabilizer or additives. I don't hold stock in Milliken, so I'm an independent freelance expert with no gains here except advising. But I think the world needs to collaborate more.
Peace and love, everyone.
Oh.
Any more questions? Yes, we do have one there.
Cécile Coriol from Domo.
Hi.
Have you checked the impact of your pigment on the other properties, mechanical, electrical, and all the other properties of the final product?
Yeah, so typically our customers are the ones who have evaluated those specific properties. For us, even in some engineering polymers, a lot of those physical property testing is new. It's something where we are working on currently to be able to enable those. We have seen that, of course, if you're using 0.5 to 1% of colorant in a formulation, because you're adding that such high amount of color, which is needed to color the polymer, Typically, you are going to see reduced mechanical properties in some applications, right? Because you're reducing the total amount of resin that's going into the final part. But we have seen that this has met still the impact requirements, the electrical requirements as well for our customers. And typically, they've been the ones to do that testing, but it's currently where we're expanding our testing as well.
For me, all that remains really is to thank you for being here, to wish you a very successful K, and maybe see you at one of the next Tech Talks in the coming days. Thank you very much indeed.
Thank you. Thank you, sir.